Hi, today let's do a teardown of this electromechanical device. This is the pedestal of an antenna which is used for the weather radar indicator WX90, the same I have described in one of my previous videos. I will place a link on the description if you want to take a look. I have a pair of this device, so I will use one for teardown and the second one will be used maybe for tests. Normally the antenna is screwed on this plate. There is a protection with this aluminium tape you can see, and the microwave input should be somewhere here, so we can see here the waveguide here, and the input is here. There is a circular connector. You can see that there are two motors inside here. These motors are used for the rotation of the antenna on that axis here. There is a play, as you can see, and there is another motor here which permits the rotation of the antenna here. So there is a spring, so there should be a servo control for this device. This is a control transformer for the feedback. There is here a switch. This thing was manufactured in 1989. You can see the hidden plate of this device. First, let's remove this cover. Okay, so there is nothing special. We can see several gears. There is a sub-D connector. So you can see that these two motors rotate together. Actually, they are not motors. The motors are here. We can see the small pinion. These two gears are probably linked to a synchro transmitter or synchro transformer for the servo control, for the feedback of this thing. The diameter of these two devices are quite large. Okay, so there is also a plate on the bottom side. So let's remove this plate. Okay, so we have an electronic board. We can see that we have 4 medium power transistors here on the top. TO126. This should be the power stage for servo control. Okay, we have an IC here, but the reference is difficult to read. It is difficult to read, but this part is an MC3346P. This IC is actually a transistor array. There is one differential pair and 3 isolated transistors. There are also 4 transistors here, 2 power resistors. And let's remove this board. You can see that we have also 4 diodes. These diodes are probably freewheeling diodes. You can see that they are connected here between the emitter of each transistor and the collector. And you can see also that we have 2 filtering capacitors. So it seems that we need a positive and a negative power supply. And they are connected through these 2 resistors, 7 ohms. And these transistors are probably the drivers for these power transistors. As we can see that the bases of these transistors, which are on the right here. This one, for example, is connected to this resistor. This resistor is connected to the collector of this one. The drive is probably provided using these 2 tracks here, these 2 signals. I don't know, it can be interesting to do the reverse engineering of these things, so maybe it can be interesting to get it work. I have removed this plate, which gives access to these 2 feedback devices, and they are actually synchro transformer. You can see here the rotor, 1 phase, 20 volts. The second one is wider. It's difficult to read. There is nothing written here. That code 81, made in USA. This is maybe a resolver, not a synchro, so that explains why there are only 4 wires and not 5. So it is written synchro something, but okay, synchro vector, something like that. I will do the reverse engineering of this board. So I will find the input of this thing and the output. So the output is connected effectively to these 2 pins here. Okay, so I have removed this connector, so we can extract this mechanical stuff. Okay, look at that. You can see that this thing is loose. Okay, so this is effectively a resolver, a synchro vector resolver. The rotor has only one phase, 20 volts. The stator, 2 phases, 43.2 volts. But as you can see, only 4 terminals are used. And the second one is also a synchro resolver. As you can see, there are 2 wires for the rotor, R1, R2, and 4 wires for the stator. We have 2 stators. So I think that the 2 motors are connected in parallel. As you can see, this screw is not completely screwed. Okay, it is better now. This motor is actually a stepper motor with reduction gears. Can be separated. You can see the gears inside. These 2 wires were left open. They were connected to nothing. The blue and black are connected to ground, and these 2 wires were connected to the stepper motor driver, which is this board actually. I have done the reverse engineering of this board. This is something like that. The motor is here. You can see that one middle coil here is connected to ground, and the motor is connected between these 2 half bridges. These 5 transistors are the transistor array actually. The pulse input is here, and in order to have a rotation of the motor, you should apply a DC voltage here. So the DC voltage comes from this transformer and these diodes and capacitors arrangement here. This is the waveguide. I don't know the purpose of this thing. High pressure side, a kind of filter. We can see that these screws are totally loose. I didn't do anything to these screws, and look at that. They are not screwed at all. I don't know how to remove this assembly. Okay, I need to remove this locking washer here. Okay, so on this thing there is an AC motor with a tachometer for the stabilization of the servo control loop, and this is a control transformer with 5 wires. So the input of this thing is a synchro transmitter, which is normally connected to the stator of this control transformer. The rotor of this synchro transformer is fed to the servo amplifier, and the servo amplifier is connected to the AC motor. So for a given position of the synchro transmitter, there is only one position of this thing, which permits to have 0 volt at the output of the synchro transformer here. So the motor will rotate this thing until the voltage is 0 on the rotor of the synchro transformer. It can be interesting to test this thing. You just need to find an amplifier for the servo control loop. This was the teardown of this radar antenna pedestal. Thanks for watching and see you next time. Bye bye.